Okay, I want to try to get to the Excel stuff fairly quickly, okay? But we are going to, in your professional lives, you're going to have problems that you need to solve within your work setting. And what we need to do is we need to somehow abstract that problem and make some simplifying assumptions that allows us to then bring the model to within an Excel framework. And then once we do that, we can perform some analysis. And there are different types of analysis that one can perform. We can perform mathematical analysis, we can perform economic analysis, but in our case, we're primarily going to perform spreadsheet analysis. And once we do that, we're going to be left with some result, okay? And the problem is that through the process of abstracting, kind of the complexities of the real problem, we may find ourselves with a result that doesn't actually lend itself well to actually be implemented. So a lot of what we're going to do and what we're going to do today is try to think about, given the results that we have, how can we perturb? How can we conduct sensitivity analysis? How robust are the results from the model that we've gotten, as we're trying to ultimately kind of come to a solution that then can be implemented. So we're going to be kind of iterating, kind of in this world, but I'm going to try to give you the skills so that as you encounter this process in your professional lives, you can be comfortable in kind of doing what these arrows are kind of asking us to do. Figure out what assumptions can we make that are defendable, okay? How can we then implement the model within a spreadsheet context? And then are we able to provide some, kind of perturbation or sensitivity analysis that allows us to feel confident that that solution actually addresses the problem that we started with? So that's the goal there. If you haven't read the Inspired Endeavors case, please pause the video and then come back for the discussion. Okay, so give me the 30-second kind of overview. The case is only less than a page, so there's not much more than 30 seconds. What is the 30-second overview of what this little story is about?
There's a toy company in Evanston, and they're two partners, and one of them wants a lower price and the other wants a higher price. And they have some assumptions about what the price should be.
Great. And so in a way, right there, they basically have a base case. They have some understanding of what they expect the price, what the market will bear. They have an expectation of what demand is for this product. They have an understanding of their cost structure. And one, they're just trying to say, should we make a go of this? Is this a feasible business? And then the next set of questions is, if we're wrong, kind of how does that, about our estimates, how does that affect our business feasibility? Everybody okay with that? Okay, very good. So what we're going to do now is I want you to open the Inspired Endeavors workbook here. And please feel welcome to pause the video if you don't have the workbook open. So here we have the Inspired Endeavors workbook. This workbook contains all of the data that was given in the case, and we're going to do the base case analysis. Let's start with the total revenue. That's going to be equal to the units sold times the price per unit. That's given in B4 times B5. To show the formulas, I'm going to use an apostrophe before the equal sign, and that converts the formula to text. To calculate the units produced, we're going to use the formula 1.05 times the units sold. And the reason why we're doing this is because we are told in the case that we have a 5% yield loss. And so our forecast is that we can sell 29,200 units, but then we need to produce 5% more so that when we have the yield loss, we'll have enough to meet the demand. So now the next thing we're going to do is calculate what is the total material cost. And to do this, we're going to set that equals to however many units we produce. In B9, we're going to incur the cost of $850, so times B10. And then to calculate the total manufacturing cost, we need to set however many units we produce multiplied by the manufacturing cost per unit. and that's going to be 521. And so note that I'm adding all of these formulas just for ease of reference. We wouldn't necessarily do this in a real model. The total variable expenses are going to be the total material cost, B11, plus the total manufacturing cost, B13. And so now we can go to and talk about what are going to be our fixed expenses. And so of course we could sum each of the different categories for fixed expenses, B17 plus B18 plus B19 and so on. But this seems very cumbersome. And so instead, we're going to be more efficient, and we are going to use the sum function to sum the values from B17 to B20. Okay, and just remember that fixed expenses are not dependent, they're independent of what we actually sell or produced. They're fixed by nature. Okay, and so now that we have calculated our variable and our fixed expense, we get to our net income or our net profit. And this is going to be our revenues less our total expenses.